In this video, I want to show you a way to get started when you're trying to factor any algebraic expression. Well, if you've been watching any of my previous factoring videos, the first thing you ever do when trying to factor an algebraic expression is to look for a greatest common factor that can be factored out. This is nice because it makes all the numbers and terms smaller and easier to work with right away. And after the greatest common factor, you'll need to see what form the expression is in, particularly how many terms are in the expression. If there are two terms, most likely you'll be looking for a difference of squares or maybe the sum or difference of cubes. If there are three terms, you'll probably be looking to use the AC method. And if there are four or more terms, you'll probably be wanting to factor the expression by grouping. So let's go ahead and see what this looks like. So we have an algebraic expression here. It's got three terms. So it looks like we're going to start by doing the greatest common factor. So I notice it starts with a negative, so let's go ahead and pull that negative out. And as far as the coefficients are concerned, I would say a 2 will come out of there. They're all even, but not a 4. And it looks like there's an x in every single term, and 3, 2, 1, so just a single x will come out as the greatest common factor. All right, well, let's go ahead and divide now all three of these terms by that greatest common factor, negative 2x. So it looks like we'll have 8x squared plus 11xy minus 10y squared. Well, I have three terms here. This is quadratic because the degree is 2. And AC method probably is going to be the best way to go. So we have our leading coefficient and then this other term. So 8 and negative 10, we're going to multiply those together and get negative 80. And what I'm doing here is I'm looking to find factors of negative 80 that will add to make positive 11. Well, factors of 80 are 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10. All right, well, probably 5 and 16 looks like that's probably our best bet. They multiplied to make a negative number, so we know the signs will be one of each, one positive, one negative. And since they add to make a positive, we know the larger will be positive. So these are all the largers and these are all the smallers. And it looks like negative 5 and positive 16 will both multiply to negative 80, but add to positive 11. So I'm going to go ahead and take that middle term, that 11xy, and I'm going to break it up into positive 16xy. And the xy has to come along because they have to be like terms, and it's whatever these terms are. And then minus 5xy. And then what I can do here is just go ahead and bring down these other two terms. They're just going to come along for the ride. Okay? And we still, of course, have our greatest common factor of negative 2x out there. So now let's go ahead and use factor by grouping, since there are four terms here, and this is the AC method anyway, and that's the middle part of that. So we still have our negative 2x. So we have these grouped. So what's the greatest common factor here? It looks like 8x. Okay, when I pull that 8x out, it looks like x plus 2y. And then the next pair, I'm going to pull out a negative, and it looks like negative 5 and y. So when I pull that negative 5y out, it looks like I have positive x and then positive 2y. Okay, well, we see here that these leftovers are the same, so I can go ahead and factor those out, because these are each factors that I can pull out. So we have negative 2x as our greatest common factor. This x plus 2y, that they had common factors here between these that we pulled out, and 8x minus 5y were these GCFs of my pairs. So here is my final fully factored expression from this original quadratic trinomial that we had. And we went about doing it by taking the greatest common factor out first, which was negative 2x. Then we noticed there were three terms, so we used the AC method. And then the AC method kind of broke this middle term up into two separate like terms. And then we used grouping and put it all together right here at the bottom. In this second example, again, we're going to start by looking to see if there's a greatest common factor. And as far as the numbers, 18, 24, 162, and 216, it looks like I can factor a 6 out of there. And as far as the variables, well, there's no x in this last term. There is a y in every term, and y to the first is the smallest. So let's go ahead and divide a 6y out. So when I do that, it looks like I have 3x cubed plus 4x squared y minus 27x minus 36y. Okay. So I have 4 terms here, so it looks like I can go ahead and tackle this by grouping. So our 6y is just going to keep coming along for the ride. So let's go ahead and look at this for grouping. So the first pair looks like an x squared I can pull out. And when I do that, I'll have 3x plus 4y. So the second pair, it leads with a negative, so let's take that negative out. And between 27 and 36, it looks like a 9. That looks like all, so negative 9. So it looks like 3x plus 4y will be left. And again, this negative here changed to a positive because I divided the negative out here. So 6y, and I have my common 3x plus 4y to both of those. And then I have x squared and minus 9. Well, x squared and the minus 9 here, this is actually a difference of perfect squares, so I can go ahead and factor this down some more as well. So I'll write down everything I have so far, and then the x squared minus 9, well, the square root of both of those, so x minus 3 and x plus 3. So here is the fully factored form of this initial algebraic expression. I started by factoring out the greatest common factor of 6y, and then I used grouping on the 4 terms that were left over, and it worked well. In this last example, it looks like I have 6 terms here in this algebraic expression, and it does not appear that there's a greatest common factor that I can pull out of all of them. So let's go ahead and divide this up. Let's look at doing 2 groups of 3 terms each. And the reason I chose that is because I see the coefficients are 12, negative 5, negative 2, 12, negative 5, negative 2. So it would work well in breaking it up like this. So the greatest common factor of this first set looks like it's going to be x cubed. So when I factor that out, I'll have 12x squared minus 5x minus 2 left over. And it looks like for the greatest common factor here is just a positive 1, because there isn't a greatest common factor bigger than 1. So when I take that out, I'm left with 12x squared minus 5x minus 2, which is the same thing as I had here also. So let's go ahead and rewrite this whole thing. So I have the x cubed plus 1, and I have the 12x squared minus 5x minus 2. And it looks like each of these factors in and of itself can be factored down even more. So the x cubed plus 1 looks like the sum of 2 cubes. So what did I cube to get x cubed? Well, x. And what did I cube to get 1? Well, 1. So I can use my sum of cubes formula, which says I'm going to take the x and the 1 and add them. And it's the square of the first one minus their product plus the square of the second one, which, because it's just x and just 1, that makes that pretty simple. Okay, so this other one, 12x squared minus 5x minus 2, it looks like the AC method again. So 12 times negative 2 makes a negative 24. So I want factors that multiply to make negative 24, and if they multiply to make a negative, we'll have 1 positive, 1 negative. But they're going to add to make negative 5. So we have our little add here. And if they add to make a negative, we know the larger one will be negative and the smaller one will be positive. So factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And it looks like right here, because we have a positive 3 and a negative 8, that multiplies to make negative 24, but adds to make my negative 5. So let's go ahead and kind of jump down here a little bit. So I'll rewrite the 12x squared, and then I'm going to break this middle term up into a positive 3x and a minus 8x, just like this, and the minus 2 comes along. And here let's do grouping again. You'll see kind of grouping is lots of places. So this 3x becomes 4x plus 1. Looks like a minus 2, so a 4x plus 1. And again, the more you do this, the quicker this whole thing will become. So 4x plus 1 is this guy that comes out of both, and then 3x minus 2. So that's the factorization for this piece that was left over. But let's go ahead and take our sum of cubes and add it to it as well. So I have the x plus 1 and the x squared minus x plus 1. So here is the fully factored form of this algebraic expression. Given this initial expression with 6 terms, I used grouping on it first, and I factored it to this point. And then notice that each of these factors could be factored even more. So here we are at the bottom. So that's kind of a quick little introduction to choosing a factoring method given some algebraic expression. You'll always start with the greatest common factor if there is one, and then you'll let the number of terms in the expression kind of dictate where you go from there.